Hello, so my name is Pandya Randhawa, and I'm going to try to teach what we covered in lecture 1 and 2 of 160. So let's get started with C++. So we right-click here, type a new file, and we can just name this week1.cc.cpp. And yeah, now we have a C++ terminal open. And to make sure we can compile, we have to go in terminal, new terminal, and it should be something over here. So to make our basic C++ program, every C++ program needs to have a main function, and that main function has to return an integer, and typically the integer is 0 when the file has successfully ran. So we do that by typing in int main bracket bracket here, and we do return 0 and semicolon to end up the program. And yeah, and to compile, it's really easy. So we're going to use G++. We type in the name of our program, so week, and to autocomplete, press tab and press enter. And yeah, now we have a file here called a.out, and to compile and to run it, we do /a tab. And then, yeah, so basically nothing's gonna happen because our program doesn't do anything. So if you want to do hello world, we have to import a library called iostream. So we do that by doing hashtag include uh, less than sign iostream, iostream, not io library. And then what we can do is like we can do std, which is a namespace, double semicolon, or no, sorry, double colon, and do type in hello world. And I forgot, we have to do std count. So count is the name of the function or method that lets us print to the terminal. And we tell Cat we want to print a hello world by streaming it to it. So to tell Cat what you want to print out, we use this less than sign and do it twice. And what this is going to do is like this is basically going to stream this like string into Cat and it'll print it. And then to tell Cat that we're done, we're going to send an end all. And yeah, so if I was to compile it again, and I can use history in terminal by just pressing the up key. So I can just press this again, and then do a.out. Cool, now we have hello world printing. And whenever we wanna do count, we'll have to keep on typing std. But if you don't wanna keep typing it, we can do using namespace std. So now we'll be able to just do count. And it should work. Cool. So yeah, that's how we do hello world. Let's say we want to declare a variable. So declaring variables in C++ is very much like Java. So we do int x. And the specific thing about C++ is that we don't have to declare a variable in order to use it. But the problem with that is like we can run into undefined behavior. So if I was to just compile this and then run it, we'll get this number. And if I was to run it again, we'll get a different number. And this is because this integer hasn't been initialized. So we haven't actually like written anything to the memory. So it just reads whatever is in the memory already. And I can try my best to demonstrate it, but I'm not too sure. If I was to show my iPad. Cool. So you have your program. So let's say that this is the memory of your PC, and then you have your program here. So this is your C++ program. So So this is your PC's RAM, and other programs use this RAM. And you know you have RAM because when you buy a PC, you can buy a 4 GB RAM or 8 GB RAM or any of that stuff. So that's what RAM is. RAM is the working memory that your computer uses to perform its calculations. And RAM gets used by all of the programs on your computer. So let's say I have League of Legends or some game. And the game is going to use up this much RAM and it's going to store data into this RAM. So let's say it stores 1x2 or whatever ID it is or anything, any type of data. And all this data is an int here because we're declaring an int. So this is an int size block of RAM. And this is used to store ints. So League of Legends will store integers here. And then once you stop playing League, the data actually doesn't get deleted. The data actually just chills here, waiting to be used by something else, which can come in and be like, actually, so I'm going to use this, so I'm going to remove this, I'm going to type in my own data. But if we don't remove the previous data, which is what we're doing when we aren't initializing the variable, we'll just end up reading the leftover data that was there before. So in C++, when we try to initialize a variable, when we declare a variable but you don't initialize it, our C++ program will just allocate a random chunk of memory to store this integer in, and it's integer size. But the thing is, it will have leftover data from whatever program was using it. And this cycle always happens. So different programs on your computer are always using RAM, and then setting it free, and then some other program will use RAM and set it free. So that's always happening. So whenever we run the program, um, our computer is like, hey, I'm running the C++ program here. I need some space. So it will start to allocate more memory. And then that's really up to the computer on where that memory is. So that's why we get all these random numbers that you see here. Yeah, that kind of makes sense. I hope it does. And whenever we run the code, it will allocate new forms of memory each time. So that's where we get the different numbers. So yeah, that's about it. So here, what we can do is we can initialize it. So now, if you were to compile, we'll actually get here, we'll actually get what we're supposed to get. And yeah, so we have a few primitive types. So we have integers. We also have doubles, and doubles let us store decimals. So this we're all familiar with. But if you were to try to store this as an int, let's see what happens. Cool. So it just gave us a warning like, hey, you're trying to store a number that is actually too big to fit into int. Let's see what happens. Yeah, and then basically it drops the numbers. So that if you did if it did like 10.9, it actually doesn't round, it just drops. So yeah, and then yeah, it'll still be 100. So what it does is like, hey, where we're going to try to store this number into our memory. So we have 109. So this is actually a double. Or basically, it'll take up more space than an integer. And it's going to try to store into a memory. And because we told it's an int, our computer program is going to be like, hey, yo, RAM, do you have any extra storage for ints? And our PC, our operating system will be like, yeah, I do have this area of memory where you can store an int. So it will try to shove the int in here, so 100, so 100, but because the double won't fit this, so this 0.9 will actually get dropped and it will just be stored as 100. Yeah, cool. So yeah, that's that. Let's briefly do some integer division. So, and I can demonstrate it using some integer division. Okay, so we have int y is equal to 50. Let's say we have 9, 10, 1 divided by 3. So what you may think, knowing what we know, is like, hey, actually, this is actually 53. But because you have to mention that's an integer, it will actually drop. So we'll only get 3. So, and the reason I was yelling at me because put on a semicolon. Yeah. So yeah, so that's why we only end up getting the 3. And yeah, that's integer division. But if you were to do, if you meant to do double, and let's try to do this. Let's compile it again. You still get 3. And you might be like, hey, why? I'm basically saying, hey, this is a double, give me a double amount of space. You should be able to have a double, you should be able to store decimals. But like the thing is, like, computers are smart and they won't allow you more space than necessary. So the compiler is like, hey, so for me to do this calculation, both of these numbers are like the size of ints. So I'm just gonna treat them as ints. And I'm gonna do the calculation in int memory to save memory. And then I'm just gonna store it into a double. So it's basically gonna do 10 divided by 3 as an int, which is equal to 3.333. But because we have an int, these digits are gonna get dropped. And then it's gonna place that 3 into here. And then the 3 is gonna be occupying a double, but it's only gonna be technically an int. So in order to force it to use double, during the division, we have to make one of them. You actually have to show the compiler like, hey, one of these numbers is actually going to be a double, so you have to properly do it. And now it should return 3.33. And there might be a bunch of 3s. Yeah, there we go. Yeah, so that's the reason why. Oops, I forgot to hide. Yeah, so that's the reason why it does that. Cool. So that's integer division. And yeah, let's try to make a program where we actually let's do a bit of control flow. So boolean or booleans are declared using bool. So let's say this bool is true. So now we're going to make an if statement. So if a, I'm gonna do count a was true. And else, so meaning else, and do count a was false. So what this is really saying is, hey, I'm gonna toss this in here, and I'm gonna analyze the value of this bool, and if it's true, I'm gonna say it's true. But if it's anything else besides true, which is gonna be false, then it's gonna print false. So let's try to compile. Cool, it says A is true, but let's say we did A is false. A is false, there we go. Let's try a 0. So I believe a 0 means false, and 1 is true. Yes. And 1. true. Let's try a different number. Let's try 49. I believe any other number besides 0 means it's automatically true. Yeah. So yeah, so that's how Booleans work. Yeah, cool. So let's try something else. So we covered let's see what we covered. Actually, I'm gonna make a new covered topics. So we covered main function, importing libraries, bool, and integer division, printing hello world. Yeah, let's try to cover, oh, it covered if else. So if else. Let's try to do, and also if you want to do, if a, let's try this. Let's try if a is equal to 49. Let's try to see if it will actually read it. But I don't think it will. It's 49. Else if, and then we do else code. Oh, it's false. Cool. That should work. Okay, so here it's saying, okay, this is never gonna. So basically, what this warning is saying is, hey, because you're storing in a bool, this 49 is just going to be recognized as true. So this logic you wrote here will actually never run. Yeah, but if you do int, let's see what happens here. Actually curious. Wait, it's true. So it exists. Let's try it. But this is going to lead to undefined behavior because it's going to be random. And if well, actually, it'll always be printing out true because like it's really rare for it to be 0, 0. If I want to see what it is, let's do this. Oh, okay, I have to compile. Yeah, see? Yeah, okay. Yeah, so that's that. Okay, let's try something else. So let's try to make a for loop. So actually, before I do for loop, let's try to capture input. So remember how I said couch? Hello, what is it? So this is gonna now print. Hello, what's your name? So if you want to capture input, what we can do is we can do cin, and then actually we have to declare a string that we store it. So let's call it string input, and we're gonna string that input in, and cin. Oh, cin. Oh, I think. Okay, why is this not working? Okay, so I have to store this somewhere. Oh shit, I know why. So basically, what's happening here is that cin is actually going to be what we type in, and it's trying to put the input into what we type, but that's not what we want. What we want to do is we actually want to, oops. What we actually want to do is we actually want to store our input as a string, and then we want to print a string. So So, so this should work. So it won't really pop me anything, but so I'm gonna do Cranberry. Cranberry, nice and cute. Cool. And if you wanted to do full name, you have to include another library called include CC type. Let's see what CC type actually is. So CC type. So here, I think we have to use, no, not S lower. Um, too lower. No, we don't want to convert. We want to have a space. Okay, no, this is to convert, my bad. We have to use a different one. I forget the name. Let me just check back to our previous notes. Oh, just gonna say this. Okay. Okay, let me take a look here. Oh, that's too lower. Okay, how do I include something without the namespace? I mean, sorry, with a space. So get line. Okay. So where the hell does get line coming from? I actually don't know. No, I don't want to clear my browsing history. Okay, get line. Get line, C focus. So std get line. Okay, so basically extracts characters until deal. Okay, so basically it basically takes in characters and it doesn't ignore spaces. Got to fix my microphone. I hope that wasn't too bad. Okay. Cool. So yeah, how we can do that is we're gonna have to do get line cn. Okay, so if we were to remove this, so what we're gonna do is so what this is gonna do is that it's going to capture input and it's gonna keep the spaces and gonna keep on going until we press enter. So, oh, did I, oh, okay, I have to, okay, I should be able to see everything. Well, so my name is Kanbir Randawa. There we go. So now it says Kanbir Randawa, nice to meet you. And it captures everything into here. So let me try to explain how that works. So we have our string, which is input. Okay, actually I can understand how this can actually be kind of confusing. Yeah, actually I'll just do this. Yeah. So we have our string and it's called input. And before, when we did cin, cin will terminate. Cin will like stop the stream, like of capturing information once it detects a space or a tab. These are called like white spaces. So we have to tell cin like, hey, we actually want to keep on getting an information um to store as strings, even if we press tab, and we want to stop it when we press enter. So what we use is we use getLine, which is a function which comes from iostream, I think, or maybe it's standard. And we basically tell like, hey, cin, you keep on doing your thing. You keep on feeding us information. And I'm gonna keep on storing information until I get an enter. And then I'm gonna put that into string. So what happens is like we actually start two cins. So I type in current here, and then the cin finishes, and then the cin starts again, and then type in Randawa, and then only when I press enter is like get on, okay, cin is now done. So cin is now done. So now I'm gonna send all the data into string, and then later on where we are gonna print the string. So that's what happens there. And that's how you're able to do what I just did right here. I think command characters. Cool. Yeah, so that's how you capture it. But let's try to do a for loop. So for, let's say for int I is equal to 0. I is less than, let's say we want to print a message three times. And then we want to increment I each times. And we can do count. Oops. Count printing 3 times. Actually, this might print 4 times. I'm a bit rusty. Okay, so let's just. Oh, it printed out 3 times 1, 2, 3. Cool. So basically, for loop logic is something that took me a long time to understand, but hopefully it makes sense. So basically, what we're doing. I'm gonna try to write on the actual thing. Okay. Yeah, and actually, that'd be too hard. Okay, screw it. Okay, so we have int I is equal to 0. Then you have I is less than 3, and then I plus plus. So we're just going to print, and then it's going to start at 0, then I is going to become, and then it's going to be like, hey, is 1 less than 3? Yes. So we're going to print again. And then I is going to come to, hey, is 2 less than 3? Yes. Then it's going to print again. And then 3 is going to be, hey, is 3 less than 3? No. And that's going to stop. So that's why we end up with 3 prints. Yeah. So let's try to do a nested for loop. So let's say we want to print a triangle. And what I mean by triangle is just we're going to print 1 hash, 2 hash, 3 hash. So you see how this makes a triangle? So that's what I'm going to try to do here. Yeah, so in order to do that, we need a nested for loop. So we do for int j. That's equal to 0. And as long as j is less than I, we're going to do I plus plus. So basically, this loop is going to keep on running until it's done, and then this will run. So I'm going to out hashtag. And then that's it. I'm actually not going to do anything. Right. Do we have to do envelope? Okay, and then for each time, I want to do a new line. Okay, this might not work, and there's only one way to find out. So /n. like this. Cool. Okay, so what I've basically done here is like, okay, this is gonna make it 0. And if 0, and basically this is gonna become 0. And then it's gonna check if this is true. So it's gonna be false in the first time, I'm not gonna print anything. And then this is gonna become a 1. I'm gonna check if this is true, then it's gonna print it. And then it's gonna keep on going until it's equal to I. Oops, okay. And then once that's done, it's gonna print a new line and hopefully it'll print a triangle. No, it didn't. But actually, I think I know why. If this will work. Cool. Okay. So because the first one is pretty redundant, that's why we're getting the first space. So what I'm gonna do is I'm actually gonna start I at 1. And I'm gonna make it if I is greater than or equal to 3. And it should actually work. Cool, there we go. We just got a little triangle. Yeah, so hopefully that makes some sense. What else can I show you? Oh, I'm still showing, hold on a second. Okay. Yeah, so what else can I show? Yeah, so I've done if else, for loops, cascade. Cool. Actually, maybe I should split this here. So you can just scrub and see what we're doing. Okay, yeah, so we've done for loops. Is there anything else that I feel like we have to cover? Yeah, that's okay, let's see. Enter number, okay. Oh dear lord. Yeah, and then also this one means or. This is just printing out the number. Oh, like the do while stuff. Okay, let's do sense-around loops. Let's do while. So a do is a loop that's always gonna run. And then a while is a loop that's only gonna run if something's true. So for example, let's say while, let's say like, so while true. And what I'm gonna do is gonna put all of this stuff into here. And for sake, I should have this so it's more readable. So while true, it's gonna run. So basically this is gonna give me the same behavior, but it's actually gonna keep on running forever. So I have to actually stop this. I'm actually not sure how. Kill it. Okay. That's an infinite loop. While false means it'll never run. Oh. CD. Okay. Cool. So it'd be never run. So yeah, that's a while loop. So let's say while bool done is equal to 0. And then after this loop finishes, what I'm going to write is I'm going to write done equals true. So this should behave the same way. Done oh, I have to put them done here. Wait, did I compile? Oh, done. Oh, done is false. So while is done is true. Well, actually, this is a bad name. I shouldn't have named it done. Um, refactor. Nope. Okay, done is probably bad name. I want to rename, change all occurrences. Okay, I want to rename it to, um, actually, leave it. Don't be too confusing. Cool. So, yeah, so that's how a while loop. Okay, let's try to make a do while loop. So a do while loop is like something we'll print each time. And so what I can do is I can actually declare the done here. So this is something that will be print. So this is something that happens each time. So it always happens first, and then this will happen. So what I'll do is like, I'm gonna print final, bruh. And then hit the window. Actually, what you can actually do is slash new line, I think. Back to slash new line. And that's also fine. So I wonder if this is within the scope. Let's see. Yeah, so basically it can't read done. So I have to declare done outside. I'll just make it rule done. And then this actually kind of back as actually screw it, I'll just declare it here. Okay, so a do happens first. Expected a what? Oh, expects a comma here. Oh, probably wants this to run. Yeah, my professor mentioned something about this. Oh, it keeps on doing. Oh, it's in a loop. Okay, I have to kill this terminal. Actually, it's a hotkey to stop code execution. C++. Um, okay, Control C. Cool. If you do Control C, it'll terminate. Okay. Um, yeah. So the reason why this is, so I don't think I want, oh, I see. Yeah, because this is actually linked to this. Ah, okay. So, okay, I see, I see. I had a misunderstanding of how do what works. No, I don't want to do that. Okay. Copy control this. Okay, game on tab. Okay, just gonna look an ugly. Cool. Okay, I think that's a bit more readable. Okay, let me do, let's not, let's just make it an integer, int 3, int a equals 3, and then I'm gonna make it, um, each time. Actually, it's kind of redundant, but I'll do minus while a is less than while a is greater than 0, and yeah, this should work. Cool. So I'm printing it a bunch of times. So this I'm a printer triangle, bruh, comes from the A. So 1, 2, 3. Yeah, so to do all, let's see what else we find here. Probably lowercase string, dude. What's lowercase string? What's lowercase string? Actually, let's try to take a whole string and the lowercase each word. Okay, I will pause. Okay, so let's continue where we left off. So last time we ran this triangle program, and if I compile it, oops, not this one, week G++, week 1, and I compile it, we get a triangle here. So yeah, that's that. So we learned how to use loops. So now let's try to actually lowercase a string. So what I want to do is I want to ask the user to type in their name. So let's store their name as string name. Cool. That should be highlighted. Yeah, there you go. So string name, and what we're gonna do is we're gonna use getLine, and we're gonna use cin and store that into name. And so now what we should do is before we actually store the name, we actually want to prompt them. So do count, please enter your name in all caps. Or it doesn't really matter, but for the sake of this, we're gonna ask them to enter in all full caps. And just to make sure it works, I'm gonna print the name after. So let's compile it. So cool. As you can see, I typed that in and I got that in. So now what I want to do is I want to take this string and I want to lowercase the whole thing. So what we can do for that is we can use a for loop. So for int I equals 0, and I is as long as I is less than or equal to name dot int I plus plus. Okay, so okay, I think that was proper. So what we can do is we can do not print, this is not Java. Count, let's say count name. I think if you do, yeah, we can do I think this works. So the square bracket lets us read the character at the position I. So what that really means is if I had a name such as let's say, so here's my name. So at each of these positions, So there'll be 0, 1, 2, 3, 4, 5, 6. So this position 0, 1, 2, 3, 4, 5, 6. And what I'm going to do is I'm going to, for as long as I is less than the length of, so for as long as I is less than 6, I'm going to keep on bumping I up, and I am going to um print I. So if I is 0, it should return K. When I is 1, it should return A, then R, then N. So what I should see on my console is this. Hopefully, I'll see that. Okay, so let's, and this I can just comment out because I don't need it right now. So cool. Yeah, and we got exactly that. But we also got, I think we also got an extra space. So I think if you remove that equals, cool. Yeah, so now we're getting my name vertically down. And what I want to do is I want to actually capitalize the whole thing. So I think this is where we use CC type. So I think if you do CC type C++, it should show that we have some here. Check if upper here. So what we're going to do is we're going to use this. We're going to use the toUpper function, which will convert the lowercase character to upper. So if you do that, so here we're printing it. So we know name works. So what we're gonna do is we're gonna want to make a new string and then print that string. So, yeah, that's let's see how that works. Okay, so we're gonna have to declare a new string. Let's just name it uppercase. And if you want to use camel type or this type, it doesn't really matter. So what I can do is rather than printing it, what I'm gonna do is I'm gonna do uppercase equals plus equals. So take whatever's in the upper and add this character. What's the function name? toUpper, and then it should do name dot I. Okay, and then what I'm gonna try to do, this may not work. I'm really going in blind, but so what I'm hoping this does is we have our we have our new string, which is uppercase, and it's blank. And what I'm going to do is I'm going to concatenate each character. So I'm first going to take this in, make it upper, and then add it there. So my string becomes K. Then I'm going to take this, make it upper, and then add it in there. Take this, make this upper, and then add it in there. And then hopefully the end result ends up being like that. So let's see if this works. So let's do one. Yeah, actually the thing kind of bleeds out. Okay, so let's do Randawa. Boom! There we go. We just got completely uppered. Okay, I'm gonna make sure that, let's see. I want to make sure that it doesn't, because this kind of blurs. Okay. Okay, that's a bit too fast. Cool. Okay, cool. We basically, yeah, so that's two upper done. Okay, now let's do random. So to random, let's see, C++ random. So where does random, so random is in, um, okay, I think I saw here it's in standard. So it should come from IOStream. Okay, so, so let's go and try to input random. So let's do int x equal round, so random integer, and then let's try to print said random integer. Okay. Okay, I got an error. Okay, what's it saying here? Error. Oh, end of. Okay, cool. Now if I run it again, cool. So you might wonder, hey, why am I getting the same number again and again? And the answer is that this isn't really random. It's something called pseudo-random. So computers are deterministic. They can't really generate random numbers that we can. Everything they do basically involves math, and whenever you do mathematical operations, the numbers are always the same. Or like the numbers are never, it's like the numbers are always like determined based on the operation you do. It's it's not like you can do a mathematical operation and you do it once and you get a number and you do it again and you get a different number. That's just not how mathematics works. You always get the same number. And computers use like math and logic. So we can't really achieve like true randomness, but we can simulate randomness. But this is an example of the computer, even though we plugged in a random function, it isn't actually being random, and this is by design. So how this random works is like this random has a seed, and the seed, if the seed is changed, then the number gets changed. But if the seed is the same, the number stays the same. So so how we can determine the seed is called S round, and then S round. So the S in S round stands for seed, and we can put in a seed. So typically the seed is 1. And we should get the same number again, 16807. If you're on Windows, it'll be a bit different just because of how it's implemented. But let's try to compile 1607, 1607. But if you change the seed, let's say to 0, we should get a different number because now the number we're feeding into the function is different. Okay, we get this big number, and if we run it again, we'll get the same number. And even if you try to compile it again, we'll still get the same number. So the only way to actually make it really random is to use something called our, so we have to, the only way to make it random is you have to have a number that's always changing. So you have to make it so like the seed is always changing, and if the seed's always changing, then the number we get will always change. And something that's always changing is time. So our computer is keeping a track of time down to like milliseconds, and or like even further. And because time's always changing, we will actually get behavior that starts to look like it's actually randomly generating new numbers. So how we can put in time into our seed is like, I think we just do this. um so okay, it's giving me an error. Too few arguments to call. um let's see, what does this do? Too few arguments. Oh, it's fixing an argument. So expects me to put in something here. Actually, let me try to do C++ time. Okay, time. Do you have to implement? Do you have to import something? I don't think so. STD time. Time. Yeah, so it should work. Okay, let's just try it out. Okay, no matching function called time. Okay, so you have IO string, you have CC type. Let's actually see where time comes from. I think it was here. srand one, no, not this one. Okay, time. C++ random time. Seeding a random number generator. Okay, I don't think we ever did null. Yeah, I don't remember that. srand. Here, srand. So, unsigned. srand unsigned int. srand state 5. Okay, I want real. So why is this so big? I want real randomness. Oh, set time 0. What's this time 0 you actually do? To library time function. So expects. Okay, time function. Time t. Okay, I think if you put in a 0, should work. Cool. They look similar, but they're different. Cool. Yeah, so these numbers are different each time. Although I'm not sure why the. I'll start with 973. Let's see. Everyone keeps on saying time t. I'm not really sure what time t is. Actually, let me pull up the textbook. And I actually really like this textbook. I strongly recommend it. And I'll show you why. So if I here type in time, or if I actually just type in, I think this should work. Okay, I'm getting a lot of here. Oh no, I'm getting algorithmic time, which is not what I want. Elementary programming. Let me find a source like srand here. Okay, yeah, so here, let's see how it works. Rand function uses the C to generate the numbers. By default, the C value is 1. To ensure the C value is different each time, you use time 0. Time 0 returns the current time in seconds elapsed since 1970. So the following code will display a random integer based on the seed. Cool. Okay. So yeah. And if you want to return an integer between 0 and 10, we do some modular arithmetic, which is do mod 10. So what mod 10 really does is, so we can, so this is kind of a concept from 2190, but it's called modular arithmetic. So basically, like, let's say you have 10, and modular arithmetic gives you the remainder. So, so we know that all of the remainders for the number 10 can only go from 0 to 9. So, so let's say we do like 10 divided by 10, that's perfect. There's no remainder than 0. If we do 10 divided by 9, well, then the remainder is going to be 9 left over. If you do 10 divided by 2, well, 2 doesn't go into 10, so remainder will always be 2, and so on. So we basically use modular arithmetic to restrict the domain of numbers to being from 0 to this number minus 1. So 10 minus 1 is 9. So let's go here and let's do 10 modulo 10. I mean x modulo 10, and we should get a random number between 0 and 9 each time. I have to compile. Cool. So 7, 1, 8, 5, 2, 9, 9 again, 3. Cool. So now, oh, I didn't turn this off. Yeah, here, I'll show you again. So now it actually looks like we're getting random numbers each time. And that's because we're using a random seed each time. So we're putting to seed, and then we're doing modular arithmetic to deliver modulo 10. And yeah, so that's basically random. And I think that's all that we covered. Covered some other small stuff like scoping, where you can determine an integer. So where you can determine an integer again. So I guess I'll cover that. Let's go. So how that kind of works is, let's say I declare an x equal to 5, and then in my if statement, which I'm gonna make it always true, if I can declare the same variable again, and then because of scoping, it will actually use the nearest one to actually determine. So if I do count x endo, okay, dude, VS Code is so slow when it comes to this stuff. Oh, I forgot this. Okay, go away, squiggly lines. Cool. Okay. Oh, wow, I did loss. So G++, week 1. Let's figure that out. Cool. So it will return 3, because even though there's 2, it will use the nearest one. But if I was to do count x here, it will return 5. So what it'll do is return 5, and then it'll return 3. Yeah. So that's scoping. And this is something you couldn't do in Java. Java would complain that, hey, this variable's already been declared. But this is generally bad coding practice because this can lead to bugs, and it's really confusing to see because you don't really know which X to track. Especially when the code base becomes large. But right now it's pretty simple. It's pretty easy. But just a heads up, it's kind of bad practice, but it's just there to show you that you can actually do this. Oh, and I forgot to return 0, which is generally good practice, but I think nowadays modern compilers know that it doesn't really matter. But if I was to return, like, I'm actually curious what to say. Yeah, so it gives me red, probably showing me that probably means like the code didn't run properly. Whereas before, when I returned 0, gave me this blue. And if I don't return anything at all, I guess the compiler's like, yeah, there's no return statement, so I'm just gonna return 1 whenever the code runs. Yeah, and that's about it. Cool. So yeah, we covered variable scoping. Wonder if there's anything else. So yeah, libraries, yeah, print it all. Yeah, yeah, we covered this. Um, variables, underscore. Probably should. Well, I didn't really cover this, but basically, there's two types of ints. There's normal integers, which cover like negative numbers to positive numbers. But if you only need positive numbers, you can use an unsigned int, and it actually covers more numbers. But like you can't have any negatives. String, yeah, we can do at and that both of them work. Integer division, scoping, random number generator. Um, yeah, that's about it. I think we should probably work with unsigned because I forgot to do that. I've actually never worked with unsigned int. So let's do unsigned x equal to code x. I'm not sure if this is actual. I'm not sure if this is actually how it's supposed to be done. And return 0. Okay, now if I would try to do negative, it shouldn't work. Yeah, so it kind of overflowed. So it can't really read the negative properly. Yeah, I actually do wonder what 2 to the power of 32 is. Yeah, so basically it's that minus 1. Yeah, so basically overflowed. So basically it went -1. So basically jumped to the highest possible number for unsigned and then did -1 and then give me 4 billion blah 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 295 instead. Yeah, so that's pretty cool to know. We didn't cover at or the brackets, so I can briefly cover that. I think string. Both of them do the same thing, but one just says down checking. String name. Okay, I have to. You gotta have it. Out name. Let's say. Let's say. Let's say I want to do like 40. So what this is gonna do is it's basically gonna print a single character from my string at position 40. And my string doesn't have 40 positions, so let's see what it does. Yeah, it prints out blank. So basically it tries to print out the 40 position, but there's nothing there, so it doesn't print anything. But if I do dot at 40, it should be like, hey, there's no 40th character in the string. Yeah, see? It's saying, yeah, this is out of range. So yeah, I guess that's it. And yeah, the X means it doesn't properly run. Cool. That's basically that. I think that's it. Yeah, so we covered everything that I remember. Cool. Okay, all right. Bye-bye.